Thank you very much. Uh, I'm just trying to share my screen. Let me know if you guys can able to see my screen, right?
Yeah, I see that now. Thanks.
Yeah. So thank you very much for this opportunity. First of all, I would like to thanks to the Ashutosh and his team. Today I'm just gonna talk about the like a topic called as a. So many people is know about load balancer is one of the mechanism. So how we can able to manage your load, whatever you are trying to getting your towards your application. But we just need to understanding about like how this is gonna work when you are dealing with this Kubernetes. Okay, so let me introduce myself first. Myself Murali here. I'm the CEO and the founder of the Client Technologies. Our company is basically dealing with the cloud and DevOps, SRE, MLOps, and apps, FinOps process. Currently we have three customers. All the customers, whatever we have, we are dealing with the cloud products. And you feel free to ask if you have any questions regarding the our DevOps or SRE or FinOps MLOps side. I'm just going to start my the topic today. It is all about the balance scale. We can just try to understanding about how this is Kubernetes going to understanding about the load balancing mastery over here. See, before I just start my the session, I would like to make you understanding about how this is load balancer technique it is going to work. Whenever you have the you when you're getting the so much traffic towards your applications, we just need to understanding about how we can able to distribute traffic to the different we can say about services. See, for that, definitely we have to understanding about the load balance is going to playing a the crucial role. If we are going to deploy the applications on any of the cloud, definitely we are trying to take the service called as AKS. Or if we go to Azure, if we go to that AWS, we have service called as a AKS Elastic Kubernetes Services, Azure Kubernetes Services. If we go to GCP, called as a Google Kubernetes Engine. But we just need to understanding about how this load balancing mechanism it is going to work in the Kubernetes. So before I just need to make you understanding about how this load balancing mechanism it is going to work. I think the call was disconnected. I think I joined again.
Hello. Yeah,
Uh,
hi. So yeah, I thought we lost. Now I is it like okay?
yes.
Yes, yes, now it's
All right. Sorry for the temporary glitch. Now I'll ask everyone like they can rejoin and yeah, Murli, go ahead.
Yeah. Before we just need to make you understanding about the how load balance is very crucial and how we can able to implemented the load balancing technique when we deploy the application Kubernetes. The first we have to understanding about like how the Kubernetes architecture it is going to work. As we know that like we have there are two things that we have to understanding about. There is something it is called as a control plane and we have something it is called as a worker nodes, right? So whenever we talk about something it is called a cluster architecture. When you talk about the control plane, which is what we can call as a master node, and we can say about worker node. In a control plane, it's just trying to understanding about what are the components which we have and how this is going to playing a very crucial role. So we have something it is called as a we can see about like Cube API server, and we have etcd, and we have scheduler, and we have control manager, right? It is basically about like where we can able to store your information. So whenever you want to do that API calls, when you do something in Kubernetes, definitely we just need to talk to something it is called as API server. And we have something called scheduler. Whenever you want to schedule a pod onto the node, definitely the scheduler is going to play placing a very crucial role. When I just talk about the control manager, it is all about like it is going to taking care of the desired thread is equal to actual state of your cluster. That means in control manager we have different types of controllers that we have. We have node controllers, we have endpoint slice controllers, and we have there are the many controllers that we have basically to manage the entire the cluster. So we know that we have the worker node, where exactly you're trying to deploy your application, right? In the worker node, basically we have something it is called as a kubelet, and we have kube proxy, and we have the ports, and we have container runtime that we have. See, right? I just want to talk about something it is called the kube proxy over here, and how this is going to be work when talk about something it is called the kube proxy. I'm just trying to touch down the basics. After that, I'll just show you that how exactly the kube and load balancer mechanism is going to work. So when talk about something it is called kube proxy, the role it is all about like networking components, right? So whenever you have deploy the application in Kubernetes, whenever you want to expose applications or the network, definitely we just need to understanding about like how this the key proxy it is going to be work. See, the key proxy is basically what we have to understanding about the network proxies basically. So whenever you're trying to create in the number of nodes, it is going to run each and every node is in a Kubernetes cluster. It is ensure is basically going to understanding about like all the networking rules, whatever we have, it is currently applied or not, and how we can able to expose the applications. There are about like there are three services that we have. Usually we do that. We have something it is called cluster IP, we have node port, and we have something it is called as a load balancer, right? So when I just talk about like the functions, right? We just need to understanding about like the service discovery, load balancing mechanism, how the networking rules it is going to be applicable. Say for example, whenever there's a pod is goes down, the new pod is getting down, getting created. Who is going to taking care, taking the all the entries, who is coming and who is going out. So because whenever you want to route the traffic to that new pod, how we can able to route the traffic to the new pod. So this all the things are it is going to matter to us. So we just need to understanding about like what's exactly going in the underlying when talk about something it is called as a load balancing mechanism. That's where we have to understanding about like we can able to operate in the user space, or we can operate in like something it is called IP tables, which is very important. Like whenever you are just trying to creating the pods, it is going to have the own IP address. Whenever you are just trying to creating this but load balancer, you're going to get the external IP addresses. We just need to understanding about like who is going to taking care of all these things. So when just talk about something it is called as a control manager, it is one of the critical component when talk about in the control plane. See, what is as responsible? Nothing but it is going to run the various controllers, ensures our the cluster it is going to match the desired status. So each controller focus on the specific aspect of the clusters. See, what is the key functions when I talk about the control manager? So because the first we have to understanding about like it is make sure the actual state of the resources match the desired state of what we have defined in the API server. This is the primary job of the control manager. It is always going to maintain the desired state is equal to actual status, and it is going to handle the failed nodes, or we have to understand how we can able to do the port recovery, how we can able to perform the resource scaling. So all this is going to taking care of and just talk about something it is called as a the control manager. As I mentioned about earlier, we have different types of control managers that we have. So there is something it is called node controller. We have replication controller, we have endpoint controller, we have the service account and token controllers. See, whenever you're trying to creating the service, in a Kubernetes, it is going to creating endpoints on each and every pod, right? So we just need to understanding about like who is going to maintain the entries. So for all these things, like there are different types of controllers that we have when just talk about the control manager. So whenever you're trying to creating the cluster on the any of this particular the cloud, definitely we have something it is called the cloud. The control manager is going to playing a crucial roles. See, when you talk about something, it is called as the load balancers, the different types of load balance techniques that we have, right? So we have something it is called as application load balancer. We have something it is called as a network load balancer. We have a gateway load balancer, the different types of load balancers that we have. So we just need to understanding about like when you're trying to creating a load balancer, it is going to work on which layer, how the functionality is going to work, what is the costing perspective. See, right now, you guys are just like, understanding about load balance technique. But when I'm just going to talk to the client, when I go for any client meeting, they really bother about the cost. So that is the reason we just need to understanding about like whenever I'm just trying to creating the applicable load balancer, how much cost it is going to be cost as. And when I just go for the creating load balancer, what kind of traffic it is going to distribute, how much it is going to cost to the client. Because the cost is one of the major factor right now in the market, how we can able to reduce the cost to every client. That is where the something which we are trying to doing something it is called as a the FinOps side here. So when I talk about the application load balancer, this is what we can call as a L7 load balancer is basically work on the layer 7. It is basically it's going to receive the traffic, which is the coming is nothing but HTTPS, or we can say the HTTP traffic. We just need to understanding about like how it is going to be charged. It is basically going to charge like in a per hourly usage, load balancing capacity. I mean to say the unit, which includes factor like how many requests it is going to processed and how much it's bandwidth that we have, how many active connections that we have. So typically this we have to understanding about it is going to be more expensive, compared to network load balancer to the advanced features whatever we have. So when I go something, it is called network load balancer. So for example, you are trying to creating the load balancer, when you just go to AWS, but you don't know about that inside how it is going to operate, right? This is where we have to understanding about like it is going to create something it is called as a network load balancer. Basically, it is going to operate on the layer 4, which is going to handle the TCP, UDP, and TLS traffic, whatever it is coming here. So it is basically we have to understanding about like what is a use case. It is the basically going to design for the order low latency, which is nothing but a high throughput use cases. Example like we have to go for the gaming applications or real-time financial systems, whatever we have. So the basically we have to handle the traffic which is coming to the TCP and UDP. Definitely we have to go for the layer 4. It is going to be charged per hour usage and per how much like the process GB of data it is going to be charged. So generally it is going to be less expensive when you compare to the application load balancer, and it is going to be high performance use cases also we have. So very high. So whenever you're trying to implementing any load balancer, you have to understanding about like how much cost it is going to costing to my client. This is a simple architecture which I want to talk about like see whenever you're trying to creating the load balancer, nothing but application load balancer where actually which is going to handle the HTTP and HTTP as request, right? But internally, what is happening in this particular application tier, where it is going to be created something it is called as a network load balancer, because it is basically tells you about like how we can able to route the traffic inside the application. So, but we think that only we have created application load balancer. We are not worried about much like what is going to be happening inside the application, how it is going to be route the traffic in all this. This is basically how they have designed, in underlying infrastructure. That's where which is, it is going to creating something. It is called as internal, what we can call as a network load balancer. If you look at this architecture, clearly it is talk about like, this is what we are trying to creating something. It is called application load balancer. When I say something, it is called internet facing. That means all the traffic, whatever it is coming towards my application, basically it is coming from this particular, internet, right? So whenever the request goes inside the application, how we can able to route this particular traffic, it is inside. It is everything. It is going to taken care by the network load balancer. See, for example, I have deployed a small application like a Kubernetes cluster. See, I have the setup already, the cluster, everything. And look at here, I have a setup something, it is called as a tuner cluster. See, for example, if we just go to here, when I type the command called kubectl get nodes, I have two nodes right now we have. So when I just type the command called as a the kubectl get deployments, if you look at my screen, I have the two deployments that we have deployed. One is something it is called as a user profile. Other one is something it is called as a MongoDB that we have done, right? And after that, what we can do is it. If you just look at my screen, if you type the command called as a kubectl and get SVC. I have deployed the application, but I wanted to expose the application over the network. So whenever I want to expose the application over the network, like what kind of mechanism that we have done. See, if you just look at clearly my screen, there is something it is called as a MongoDB server, which type it is something it is called cluster IP address. And when I just look at here user node, which is nothing but my front end application, when I just wanted to access my application over the internet, I have just created something, it is called load balancer, right? You just look at here, there is something it is called cluster IP address also it's created. And also there is something it is called as external IP address also got created, right? This is nothing but my load balancer URL. And this is nothing but my port number and which port number I want to expose my application. But the many of the people, they don't bother about like what it is exactly, what is the port number, why it is created, all these things. See, whenever you are trying to deploy the application in Kubernetes, whenever you want to access the application over the network, whether you go for the third-party load balance mechanism called as a HA proxy or Nginx, if there are go for the any third-party load balancer mechanism, or whenever you want to expose the applications by using load balancer, this is what we can call as external load balancer, which is going to provide by the cloud provider. It is not provided by the Kubernetes. See, whenever you are trying to creating any load balancer in Azure or GCP or AWS, it is basically going to provide by something it is called as a cloud, a native, the provider, right? So, but I want to ask a question like you are accessing the application with this URL and the port number 3130, right? See, for example, if I'm just trying to fill my details, I'm just trying to perform the registration. Let's say, for example, I'm just trying to put my look at my screen. I've just put my email address. I'm just putting this particular the phone number, and after that, I'm just trying to perform this particular, entering all address and all these things. After that, let me just try to provide the password, right? So when I click on the register right now, you can just look at here, the registration is successful, right? It is asking us to provide the email, and it is going to asking us to provide the password, right? So when I provide this factor the password, when I just click on the login right now, so it is asking us to enter the OTP, right? I mean, say uh, I have just implemented something. It is called as a OTP. So let me just going to enter the OTP which I have received to my which I have received to my email. See, for example, the OTP it is saying about like, the 7-3. And if we just go for the 427, when I click on this login page here, it is going to verify the OTP and it is going to take me to inside my home page of this particular application, right? So when I just go for the home, and if you just go for the about us, if you go for the services, so this is everything that that like I have deployed the application. I'm just trying to accessing my like an application to the like load balancer external IP address. We can say that that this is going to be mapped to your domains. Whenever you type flipkart.com, it is going to hit this particular URL. We had to configure the backend. We had to create record all these things that we could do that, right? So this is nothing but my application which I deployed. See, whenever the more customers are trying to access my application, how this is going to be route the traffic inside the cluster? That is what my question is right now. So if you just look at my screen, this is nothing but my, the service port number. This is what we have to understanding about something. It is called as a node port number, because this load balancer is going to create the external out of the cluster, but it cannot able to route the traffic inside the cluster. But how this is going to be route the traffic inside the cluster? That is what is my point I would like to explain over here. See, if you look at my diagram that what we have mentioned, This is nothing but my load balancer IP, and we have put the service port number. See, the moment when you are trying to hit the URL, the request goes to where means the first request go to your node port service. As I mentioned earlier, like whenever you want to expose the applications in Kubernetes, there are three kind of services that we have. One is nothing but cluster IP service, and one is one thing node IP node port, and we have something it is called load balancer, right? Whenever you are trying to create a load balancer, it is going to create the external load balancer, which is going to provide the cloud provider network. And here, if you just look at here, it is going to open this particular port number called as a node port number. Because why? Because node port, it is going to expose the application over the top of the node. So it is going to route the traffic inside this cluster. We can see that this is all my node, right? It is going to open one static port number in top of each and every node. Whenever you send the request, the request first go to your the request first go to where the request go to your node port service. From node port services go to your endpoint. So whenever you are trying to creating the any service, it is going to create the endpoint. See, for example, if you look at my screen, when I type the command called as a the keep curtle get pods, you see the about like how many pods that you have. So I have total the 5 pods are running. So when I just type the command called keep curtle get pods hyphen -o wide, when I mention, you're going to get the 5 IP addresses, right? So now if I just type the command called as a the keep curtle get SVC, I have this particular service port number. When you type the command called keep curtle describe, and when I mentioned about like SVC, so I'm just trying to put something. It is called as my service port number. Sorry, my service name. I'm describing my service name. Okay. So if we just type describe, we can see about like load balancing address is got created. And you just look at here, this is nothing but endpoints. See, this is nothing but one endpoint right now. This is another endpoint. This is the another endpoint. That means my what are the front end application that we have? This front application is basically I have deployed in the 3 pods running. So on each and every pod, if you look at here, there is one endpoint it is got opened. So it is showing about like 192.168. You can just look at here 19.156. If we just match this IP address over here, it is going to be match. You see that one is something it is 156, and we have 76, and we have 78. These are the IP addresses, whatever we have, it is got created. And look at the, this is what is nothing but my service port number. See, this is nothing but my node port number. Okay. The request is basically it is comes towards your node port service. From node port service, it is goes to your endpoint. See, as I mentioned about the why we are going to use node port service means we want to expose the application over top of the node. So it is going to route the traffic inside this particular cluster by using something it is called as a node port service. And internally, it is going to use the load balancing mechanism for the using this factor, the cluster IP address. This is exactly that how this is going to be route the traffic when you talk about something it is called as a how this is going to work when you're going to use something it is called a load port service in the Kubernetes service. If you look at these points that what I mentioned over here, if you just look at here, the external load balancer, whenever you are going to create it, it is going to create the outside the cluster. It is going to listens on the specific port numbers. It is going to forward the traffic to the nodes hosting on the corresponding pods. The traffic it is going to route it using the node port service. It is not going to route the traffic by using load balancer. So this is something that we have to understand everyone. That is the reason I just brought up this small topic I want to explain so that you get understanding about like how it is going to work in a underlying infrastructure. So this node port service, whatever we have, this node port that are automatically managed by the Kubernetes. See, when I created the Kubernetes service, I didn't mention about like need to create node port service. I mentioned about only to create a service port number. So service port number, I want to expose my application, but who created the node port service? The node port service is automatically be created by the Kubernetes. See that the cloud provider's load balancer may also perform the health checks on the nodes, the pods ensure the traffic only send to healthy instances. You know that load balancer will accelerate external traffic. it is going to route to a particular node. So, but before it is going to send to a particular node, it is going to check the health of the server, right? That is, it is going to do it with help of the ping request. That is how it is going to do that. See, the load balancer itself is external to the cluster. Typically, it is going to manage by the cloud providers. So, whenever you have the multiple services, when you want to perform the path-based routing, or when you want to perform the domain-based routing, definitely we have to use something. It is called ingress, right? You might aware about like Nginx and HA proxy. It is also going to provide another cloud provider. It is going to provide the load balancer. This is what we can call as a third-party load balancers. You might heard about the FI load balancer. See, for example, you might guys using the railways, right? IRCTs.co.in, you are going to use to book the ticketing system, right? And we have the passenger railway ticket system that we have. So this application is basically going to use FI load balancer, because when I have been to Delhi, when I visited there, the CRIS, nothing but Central Railway Information System, I have trained them for the DevSecOps in that project. I had chance to visit their data centers. I've seen how the data centers, what load balance they're using, and how much storage they're using. All these things. I got a chance to use that. So, but they're using Red Hat OpenShift. To that, they're using the FI load balancers. Is that the Kubernetes does not create load balancer within the cluster. It relies on the cloud provider's native load balancer infrastructure. It is basically created by the who it is going to provide by this particular the cloud providers network. So if you're running Kubernetes on bare metal in on premises, or we can see the platform without cloud integration, so we need to set up a load balancer manually, or alternatively we have to use this particular metal LB, or we have to go for the third party load balancers. That is how we just need to do that. This is how we just need to understanding about like it is going to work load balancer, route the traffic internally inside the cluster. So I hope you guys understood, right? If you have any questions, I can take up your questions. I can able to the clarify all your doubts.